Hello everyone, welcome back to the course on CATIA. Today we will be talking about a different topic which is probably not from basics of CATIA. This is a bit advanced strategy that design engineers or industries are using. You must be aware about the reverse engineering. What exactly the reverse engineering is? We do have one particular component in our hand, and what we do is we measure that particular component and create some sort of CAD model. We generally refer this particular thing as the reverse engineering. This remastering, our today's topic, is again, I can say that this is a branch or this is a method of remastering. But here we don't have any particular model, physical model is not available. We do have one model available, which is a non-parametric model, and what we have to do is we have to measure that, we have to use that, and by using that, by measuring that, we will have to create a parametric model. You must be aware about what parametric model is. We had already discussed that what exactly the parametric model is. So this is what we are going to do in the remastering. If I'll talk about the definition or the generic idea about remastering or this method of reverse engineering. So remastering is creation of a parametric model from a non-parametric model using it as a reference but without maintaining the dependencies. Very clear definition we have that we have to create a parametric model from given non-parametric model using that non-parametric one as a reference, but when I'll be maintaining the reference, I don't want to maintain the dependencies on that, which simply means if I'll delete the non-parametric model, my parametric model should not get affected. It is also known as the method of reconstruction of parametric model. Normally what happens is, basically we do have the shape available, but we have no idea about the size. So from that non-parametric model where we have the shape available, what we do, we measure, we analyze, or we project that particular shape and create or reconstruct the parametric model, but we don't want to maintain the dependencies between that. And when we have the parametric model available, definitely we can go for further modification, further upgradation into that parametric model. But doing all these things in the non-parametric, it is a little bit difficult and not accepted in the industries. So that's why what we do is we perform the remastering. If you are looking for an opportunity in the design domain, then definitely this is one of the kind of tool test that you may get in the industries. If you are going for an interview, going for a tool test, then definitely you will find remastering as a method of evaluation, because majority of industries, yes, they are working on remastering along with new product development or upgradation into the existing product. Yes, remastering is also a part of that structure. It is not always that we do have some drawing or some reference available and we will have to create the model. No, it's not like that. Majority of industries, yes, they are working for remastering as well. Let's understand how exactly we can perform the remastering, or what all methods we have to do the remastering or this reverse engineering. So basically there are two ways for performing the remastering. First one is the solid remastering, second one is the surface remastering. Solid remastering, basically what we have is we will have one dead solid being given, a non-parametric solid being given. Definitely it will come to us in the file extension, which is the neutral file format .stp. When we will open that .stp file, we will have some solid available. It will probably be a sheet metal model, sheet metal bracket or something will be there. So that STP file is available as a solid. What we have to do, we have to use the part design workbench, and using the part design workbench, what we will be doing, we will be reconstructing the parametric body or parametric model. Second approach or second method that we have is the surface remastering. So here we can get input as a solid or as a surface, and what we will have to do is we will have to create the parametric surface. Definitely if a solid is given, we will consider the outer surface of that. We will take the references from the outer surface of that and we will start creating the outer surface. Or if a surface is given, then we can go for some extracting the geometries and we can construct the outer surface. Once that outer surface, a single surface is available, which is a parametric one, we can apply the thickness for converting it into solid. Definitely the result will always be solid only, as the surface has no existence. We cannot define the thickness of surface because it doesn't exist. So these are the two methodology or two approaches, or I would say two types of tool tests you may face while appearing for an interview or tool test. Let's explore the solid remastering first. What exactly will happen in the solid remastering? So in this particular session, we will be covering each and every step of solid remastering, how exactly we have to perform the remastering. Definitely the features that we are going to use, those features will be from the part design workbench only. Whatever we have explored in our previous videos, it may be pad, pocket, shaft, groove, rib, slot, hole, some dress up features like fillet, chamfers. These are the I would say features we are going to use. We will be using the multiple body concepts as well. We may use Boolean operation in that. Also, we will be using the measure toolbar. So I would recommend you, before going on to the remastering, just go through the videos, go through the sessions that we have covered on the part design workbench. These features we have already covered in that. Now let's move on to the solid remastering. To start with the solid remastering, I have this one particular input given to me. The input is basically one .stp file, which is a neutral file format. I will have to start from this .stp file and I'll have to create the parametric model. First, what I'll do is I'll open my CATIA software, and this .stp file, I can import it or I can directly select and drag it into the software. And now I can minimize the folder. So this is how the file will open in front of me. You can see there is transfer complete dialog box appear, that this particular thing has been transferred, and I can see the access system. You might see the planes. It depends how you have defined the settings. If I'll talk about the tree, so there is a part 1, 3 planes which are hidden. Access system is there. Probably we don't need that, so I can delete it, no issue. There is a body manifold dead, and in that body we have one solid available. So now you can see, if I'll talk about the planes, so I have these 3 planes available over here. I can simply say over there I have the origin available. But when I'll import the .stp file, what will happen is I'll not be able to judge the position, the orientation of the particular model. If I'll go for isometric view, I'll be getting the isometric view. If I'll go for fit all in, then this is how I am going to get the particular object which was there in .stp file. Now you can see this particular model, I cannot say that this would fit in my front view. You can see the orientation in the front view. Definitely it is not going to fit, and it is not there at the origin. It is somewhere in the space, and orientation again we cannot judge it. So what we'll have to do is we will be hiding the planes or the access system which is available for the particular file. Means I am not going to use the origin of file. I am not going to use 0, 0, 0. What I will be doing is I will be using this particular model only, and with respect to this model only I will be defining all those required things. Just like if I'll talk about, let's say for a particular model, if I'll go for simple part design, I want to design a particular part, I want to model a particular part. What I'll be doing, first I must have the origin, I must have the planes available. After that only I can go for creating the sketches, applying the features and create that as a solid. So the same thing I'm going to do here, and make sure we don't want to maintain the dependencies. So here what I'm going to do is, first I'm going to define origin. I'll be defining the origin with respect to this non-parametric solid, but I'm going to define that for my parametric solid. This is what we are going to do. So we do have this toolbar available with us. This toolbar is a reference element toolbar. In this reference element toolbar we have the point. I'll be selecting the point and I will take the reference of this. Somewhere on this particular model I'll be defining this point, and this point would act as the origin for my parametric model. So if you can see, if you rotate this particular model, probably you will be understanding that this particular model is symmetric, and symmetric about this center. So what I'll do, for defining the point, for defining the origin, I'll select this edge, and on the middle of this edge I'll be defining the point. I'll say OK. So there is one point being defined, and this particular point, point 1, this will be acting as the origin for me, origin for my parametric model. Now we talked about creation of parametric solid from non-parametric using non-parametric, but don't maintain the dependency. So every time we work with the particular remastering, whatever we create, whether it is a reference, whether it is a sketch or feature, it is necessary for us to check the dependency. So what I'll do, I will check the dependency. For checking the dependency, simple method, just try deleting the non-parametric solid. When I'm deleting the non-parametric solid, in the dialog box I have turned on delete all children's. What is happening? My point is also getting deleted, which simply means your point is dependent on the dead solid. We don't want that. What we want it to be independent. For making it independent, I'll right click on point, I'll go for point object, and I will say isolate. When I'll say isolate, the symbol before the point will change. When the symbol will change, it will be isolated. Now try deleting the dead solid. It got deleted. It has no dependency. Okay, so point is independent, which simply means our first step, which is creation of the origin, is done. It is independent, and it is by taking the reference of dead solid. Next, what we need is planes. So if I'll talk about the planes, so x, y, y, z and zx planes are there, but they are at the origin, and again orientation is not matching. In that case, what we'll be doing, we'll hide them, and over here on the particular origin and matching its orientation, we will create one access system here. So I will insert an access system. While inserting the access system, again I have a dialog box. It is asking for origin, so I will select point 1 as the origin. Now you can see the orientation. Orientation is little bit disturbed. Actually this orientation is by default as per the file. It is not as per the model given to us. So what we need is, we need the orientation to be as per model. So what I'll do, I'll select x-axis reference as this edge. So x-axis will be aligned with this edge. y-axis reference as say this one. Now you can see the orientation of axis system is fine because we are using the dead solid as a reference, right? I'll turn off this current option and I'll say okay. Axis system is created. Now again check the dependency. So when I'm deleting the manifold dead or this dead solid, my axis system is getting deleted, which simply means it is dependent. What we'll need to do, we will need to isolate this as well. Now this is isolated, again check it. Fine. So step number 2 was to create the axis system. Now we have origin, now we have axis system available and both are independent. Let's start creating the model now. So for creating the model, it would be better that I'll create some sketch over there on the XY plane, and to that I can apply the pad like this. So I'll go for creating the sketch. I'll definitely be using positioned sketch on the XY plane. Check the orientation properly and say okay. This is how the sketcher environment would look to me, that okay, this particular one is the sketcher one. Now what I'll do, I'll have to create the sketches here. But again, we are talking about maintaining the dependencies. So when we want to maintain the dependencies, what we would do? We would prefer to go for projecting. Again, it is never recommended to include the fillets in the sketches because it makes our sketch very difficult to work with. So what we do, we prefer to apply all the fillets as a feature later on. If any critical curves comes into picture, then definitely we will prefer those curves in the sketches. Otherwise, we will not prefer to include the curves or fillets in the sketches. So what I'll do, I will project this particular geometry, but I will not project it completely. I'll go for projection and I will project the straight curves, say horizontal one, this aligned one. These curves only I'll be projecting. Say this one, over here, this one, and say this one. These curves I have projected, and now I can exit the workbench. This is how my sketch would look like. Now check the dependency first. So I'll delete the manifold. Sketch is also getting deleted because yes, we know when we go for project, it will definitely maintain the dependency we have used in creation of part models and all these things. Now what we would prefer is, we'll prefer to isolate the sketch first and then we will be working on the sketch. I'll go for right click and I will isolate the sketch as well. Isolated and independent. Now enter into the sketch. If you are getting some difficulty, then you can hide the manifold, and this is how you have the particular sketch looking like. Now since we have isolated, what will happen? Each and every curve of this particular sketch is independent. If by mistake you have little bit moved it, it would be difficult for you to manage later on. So first what I'll do is I'll make it as a closed loop. So I'll go for this option, trim, select it using double click so that it would be easy. It would be activated after use as well. First I will make a closed loop here. Make sure you follow the curves so that you will not be able to miss any curve. So this is a closed loop. Again, I have not moved a single curve. I have just extended and trimmed that because I have no idea about the parameters. Okay, now what we'll be doing, we'll be applying the constraints on this. So this particular line will have definitely the vertical constraint. I'll select this, I'll go for this dialog box and vertical. Similarly, using control 1, 2, 3, these three lines will have the horizontal constraint. I'll be applying that, and then I can apply the dimensions. Before that, this vertical line has to be coincided with the vertical axis. I'll make sure that this goes coincided. This one again, horizontal line coincided on the horizontal axis, and now you can see it is turning into green. Why? Because we are making it fully constraints. So you keep on applying the dimensions which you feel are important from the particular model point of view. Make sure it has to be fully constrained, and we are not defining any dimension value. We are just giving it the value. Whatever is coming, we have considered that as the final value, because we have no idea about its measurement. What we have idea about is only its shape. So now the complete object looks green. If you want, you can go for checking the sketch solving status. It is ISO constraints. Okay, fine. I'll exit the sketch and turn on the dead solid. Now we have the first sketch available for our parametric model, and which is completely independent. What we'll be doing, we'll have to apply the feature. To this sketch, I want to add some material. For adding some material, I would prefer to go for pad feature. Before going on to the pad feature, what we'll be defining? We'll be defining one body. So I'll insert a body. Body 2 is here. Right click, go for properties, and here you can change the name. Let's say I'll be giving parametric, and you can change the color as well, so that you will be able to differentiate between two models. I'll say okay. And now in this parametric body, what I will have is the pad feature on this, and now it is asking me the value for the pad. As this particular model is symmetric, what we can do is, I'll cancel it for now. What I can do, I can go for utilizing the measure toolbar. I'll select the measure between this face, and I'll measure purposefully, I'll measure between the plane. So the value is coming out to be 31.7. I'll remember the value, and I'll go for pad on this sketch with the value 31.7 and make it mirrored extend, preview, and say okay. This is one of the method that I can do. Another method what we can utilize is from the feature itself, whether it is pad, pocket, shaft, groove. From the feature itself, I will execute the measuring features. How? Let's see. So now you can see, since we have given different colors, now I can see that there is a difference, or some particular feature is missing. Just like you can see here, we have the curve, the fillet, but in the parametric one we have the sharp edge. What I'll do, I'll go for applying the fillet on this edge, and now I don't have the idea about the value. So what I can do, from this radius, instead of giving some value, I'll right click here and I'll execute measure item. When I'll go for measure item, this box will appear and I can measure the particular item, say this fillet. I'll be able to get the value. So radius is 15. Make sure when you are doing this particular thing, keep measure, has to be turned off. If you will not turn this off, then it will keep the value and it will maintain the dimensional dependency. So I will turn this off and say okay. As soon as I'll turn this off, it will give me one dialog box. The measure is not associative. The result is copied as a value, and this is what we wanted. We wanted the result to be copied as the value only. We don't want to maintain the dependency. I'll say okay, and now you can see that 15 value is automatically copied into the radius column. Say okay. So that 15 radius is applied. Similarly, we can apply other fillets as well. So I'll go for fillet. Now I'll select these two edges together because I know that these two edges will have the same value. And I'll go for right click, measure item, select this edge, 14.2, keep measure as off, say okay, value copied, say OK. Similarly here also we can do the same. If you are not comfortable doing this, then you can do that. You can hide the parametric body. You can go for measure item separately, measure the particular radius value, measure item, measuring this value 18.75 it is. Then you can show the parametric, you can hide non-parametric, select it, edge 18.75, and you can say OK. This will also work, no issue. This might take some time initially, but later on, yes, you will be able to do that. Also, we have some fillet here as well. Now I remembered the value from earlier, it is 100 mm, I can apply it. This much work is done for us. So what we had done, we had created the sketch and we had applied the pad, and later on we had applied the fillets as well. Check the dependency. Yeah, it is completely fine. Now what next we have to do? Next we can apply shell on this. Since this is a tangent edge or tangent face, sorry, I can apply shell very well. So what I'll do, I'll go for applying shell, select the particular face, the complete face will be available, and here I'll go for again right click, measure between. Now measure between, it will be a difficult case for me to understand here, so I can immediately hide the parametric body. Within the feature itself I can hide it. Select the first face, select the second face, value is coming out to be 4.2, keep measure off, say OK, result copied, OK, 4.2 is here. You can show the parametric body and say OK. This is how you are going to get the result here. So this much work is done. Now the remaining thing we have is the holes. So what we have to do is we have to create 3 holes here. Now these 3 holes, basically when we talk about hole, so hole is determined by means of point, because we talk about the position of hole. When these are getting determined by means of points, then definitely what we need to do is we need to define the points first. So I can hide parametric for now, and by taking the reference of dead solid, I'll be defining 3 points. Point on the center of the circle. So here we have the point available. Similarly over here and over here. We have defined these 3 points. Definitely these 3 points will be completely dependent. So what we can do is we can isolate them first, so that these points will be independent. And next what we will be doing is we will be creating the holes. I will hide the dead solid now. Yeah, we will be creating the hole feature on this isolated point, but on the face of parametric solid. So we will have the feature available. Now we just want to measure it. So within the feature only, I can go for blind hole. Instead of blind, I can go for up to next, and here diameter, I'll right click, go for measure item, and now I'll turn on the dead solid, measure it, and radius is coming out to be 6. Remember, when I'm going for measure item, it is giving me the radius. Keep measure off, say OK. So the radius value will be as it is copied. Make sure here we have to give the diameter value. So you can go for multiply by 2 and say OK. Make sure that you are measuring the radius value, but input is diameter value. Second thing what you can do is you can go for measure item first from this. So 7.75 is the value, radius value. I'll hide this, go for hole, this point, this face, and here 7.75 into 2 as the value, and instead of up to next I'll go for up to last, so that it will cover the other side as well. Similarly here I have to do point this face, and the values are same, so I'll say okay. So this is the parametric solid I have available using the dead solid. You can see if I'll compare visually, then it looks fine. Let's check the dependency for the final time. If I'll delete the dead solid, it will get deleted and it is not affecting anything. Okay, hide this. Now we have created the model, we have the references, but the problem is it is independent of everything, because we have defined the origin, we have defined the axis system, we have also defined the points for holes, and all are isolated, all are independent of each other. What we will have to do is we will have to define the dependencies in between them. How? I'll double click on the axis system, because axis system has to be dependent on origin. I'll double click on the axis system. Since we have isolated that, the by default type will be explicit. What I'll do, I'll change it to standard. When I'll go for a standard, it will ask me for the origin. I'll give the origin as 0.1. When I'll give that, what will happen? The orientation will change. If the orientation will change, it will be difficult for me to maintain these three holes. So instead of axis system, first I'll go for making the changes in these 3 points. Okay, we'll be going reverse. First I'll make these 3 points dependent on axis system, and then axis system dependent on point, the origin. And if I'll move the origin, my complete model has to be moved. So point number 7, double click, change the type from explicit to coordinates. Here axis system, select this one as the axis system. It will say what it will do, based on the axis system, it will automatically measure all the distances. So in x it is 0, in y it is 54.59, in z it is 0. I'll say okay. So point 7 is completely dependent on axis system too. Next, point 6, same thing we have to do. Axis system, this one. If you are not selecting the axis system, by default it will take the 0, 0, 0 of the file. Now you can see it has measured x, y and z values. Point 5 again, coordinates, axis system, this one. Say okay. Yeah. So point 5, 6, 7 are completely dependent on the axis system. If needed, then I can definitely hide them, no problem. Now axis system, double click on that, change it to standard type and change the origin. Now it doesn't matter what orientation it takes, because everything else is created, it is dependent on the axis system. So if the orientation of axis system changes, the complete model will automatically be shifted. It has shifted, doesn't matter. See, this was the orientation that from the .stp we got, and this is the actual orientation. Now we have the origin, double click on this, change its type as well, make it coordinate. So now you can see with respect to the origin of the particular file, it is at this coordinate. If you want, you can move it to 0, 0, 0 as well, no issue. And make sure the matter is all about the dependencies. Now this is our parametric model we have. Now I don't need the manifold. For now I will be hiding this. Yes, so this is the parametric model I have, which I had created by taking the reference of non-parametric, but I have not maintained any dependency. For this particular model, for this particular bracket, I have complete feature tree, I have all its sketches, all the references available. If any further modification comes into picture, then I don't need to ask for anything. I'll just make the necessary modification in the available features and I will be able to update it. This is what the remastering is. I hope you all are clear with the remastering. I'll be attaching this particular model in the description. I'll be giving you the drive link so that you can download it, the same STP file. You can import it in CATIA and you can try the complete procedure so that you will be able to understand what exactly the remastering is. For further models, for further practicing, you can reach out to us. You can mention this in the comment box. We will be providing it to you. I hope it is clear to you. Thank you very much.